Newton's first law of motion states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force.
So for the first example of Newton's first law of motion is shaking a bottle of sauce. You need to turn it upside down and thrust downward at high speed and then abruptly halted, as you can see in this video. So the inertia of the sauce itself will cause it to keep going and come out of the bottle.
The law of inertia is also commonly experienced when riding on the road base. As we can see in the video, when the motorcycle brakes, the rider's body tends to lean in the forward direction. This is because the rider's mass will keep moving at its original speed in a straight line until acted upon by forces like air resistance and friction. This also happens on bicycles, in cars, and aircraft.
Newton's second law of motion is F equal to ma. The second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object increases, the acceleration of the object increases. As the mass of an object increases, the acceleration of the object decreases.
As example, if we kick a ball with a small force, the acceleration of the ball will be lower. Meanwhile, if we kick the same ball with a higher force, the acceleration of the ball will be higher.
When an object is thrown from a certain height, the gravitational pull of the Earth helps it to develop acceleration. The acceleration increases as the object advances towards the Earth. According to Newton's second law of motion, the acceleration developed by a body is directly proportional to the force. When the object hits the ground, the impact force comes into action.
This is the reason why a brittle object thrown from a tall building suffers more deformity than the situation where the same object is thrown from a comparatively shorter building.
In balloon experiments, Newton's law states that for every action, there is an equal but opposite reaction. As the air is released out of the balloon in one direction, the force propels the balloon in the other direction. This equal but opposite force causes the balloon to fly like a rocket.
So bouncy balls are a great example of Newton's law of motion because every time the ball is bouncing, there is action-reaction forces. So the action force is when the ball has been dropped to the floor or thrown, for example, while the reaction force is when the ball bounces up from the ground or bounces back from the object it was thrown at.